Hello everyone, welcome back to my channel. Yes, I can crack the interviews using Java. As I mentioned in my previous video that we are gonna target another problem which is average at each level of the node, and we will be discussing about it in detail. Before I proceed with respect to this particular problem, I'm gonna solve it in a different way, but eventually I will show you how you can solve multiple binary tree problems uh, with respect to the same technique but having a different kind of tweaks. So I can solve this problem using my previous example exactly same by just changing few things here and there, but I don't want to introduce that technique right now. I just wanted to introduce a few different pattern what you can follow, and whichever you are comfortable with you can choose that and you can solve multiple problems. Let's talk about this problem. So we are targeting that average at each level of all the nodes. So if you see here, this is the level 1. It's 1 because there's no leaf, there's nothing. I mean, leaf is there, there's no other sibling. So here 2 plus 3 5 divided by 2, which is 2.5. 6 plus 5 divided by 2, because number of nodes are 2, level is same, so it is going to be 5.5, and so on. So we are going to solve this problem by Java code, and we can definitely revisit this problem after upcoming videos where I can consolidate like how many problems you can solve using the same technique, and wherever you need to tweak the logic I can pinpoint that at that point of time. So the way we are going to try solving this problem is at this point of time is again an iteration where there are two while loops. Now the question is, what is the while loop? So we can discuss each and everything in detail. Let's talk about this binary tree. As I mentioned in my previous video that how you convert this binary tree into the Java code of binary tree. So I have created tree node right here. You can see tree node which has a value which is nothing but 1 2 3 5 and so on, and has a left and right nodes. Okay, so we have created a root of left is what, 2. Okay, root of left is 2, root of left is 6, root of left is 2. Yes, root of left and left to right is 7, root of left to right is 7. Yeah, so that's how you define left or right pattern of a binary tree in Java, and you have your own tree node, and very particularly you can name it whatsoever you wanted to name it. There's no specific reason you say tree node or a node or binary tree node or whatever you wanted to call it, you can call it. There's no thumb rule around that. So my binary tree is defined in my main class. Okay, so I got my binary tree, I got my root. So if you see right here, so my root is with full of tree structure, and I'm going to pass this to the function called average of node value at each level. Let's take a look. So now my root is just not a root as a one single node. It has whole tree structure, what you can see right here. It has everything in it, and we can traverse all over the place, and we can see how it is solving the problem. So this is the average list, which is as a output of this particular problem statement, which will contain all the averages at each level of the nodes. So as I mentioned in previous video, again I'm keep saying about my previous video, because we will be solving the same problem or similar problems in a similar fashion over and over. So if you keep thinking, okay, I just pick up this database or this data structure, probably you can achieve the solution very quickly. So let's talk about it. So I have defined a linked list, which is nothing but a queue. You can say linked list here as well, doesn't matter. You just have to have different kind of retrieval and put the data in it, but that's fine. So I've just defined as a queue. I put my root into the queue. Okay, now my queue is filled with the root, which is whole tree now. Okay, next thing is I initialize some of the local variables, which is sum, node count, and level is equal to 1. This level equal to 1 is just for understanding purposes, nothing to do with this problem. I just wanted to make sure that whosoever is watching this video will understand that how levels are getting increased or decreased or getting calculated. It's just for the debugging purpose as of now, but it's nice to have it as of now. So what we have to do, we have to start from the root, and at every node we have to see whether there is any sibling of it, and if so, then at that level how many nodes are there, and we have to collect all the nodes, sum it up, divided by number of nodes, and get the average at that particular level. So first while loop is for checking whether my queue is empty. No, because we have already added root, so it's not empty. Go inside and we initialize variable sum as 0, node count as 0, level is already there. Now this is the inner level nodes queue. So basically what this particular object or data structure, which is a linked list, is gonna contain is all the values, all the nodes at each level. Okay, so now we have to say, okay, if q is not empty, which is not empty, true, then go inside q.remove. When you say q.remove, what it will return me back is my first node, because it's just my FIFO. So I just took my node and I said, okay, give me a node dot value. It will give me 1 at that point of time, and I'm saying that sum plus equal to node dot value, and sum is 0. So 0 plus 1 is 1. Okay. Then I will say, okay, and node count plus plus, and go ahead with say node dot left. If there is a left is not equal to null, add to the inner level. And if node right is not equal to null, then add to this inner level node and keep looping through. So what happened at the very first iteration, it will be the one node and then it will be the two nodes and so on. And then after traversing all the nodes at each level, what we are trying to print, sum of all the nodes value at level whatever level you have. And this is just, as I mentioned earlier, is the debugging purpose, and the sum and the node count. Once you have done this, once you are out of this while loop, you assume that, I mean, you understand that you are at this level or at this level or at this level or at this level. So this while loop is taking care of each level and the number of nodes within that given level. That's what this while loop is doing. So once you are done with that level, this while loop is over, and that it will go all the way to the top and all the way to the top, and this queue is keep filling. I mean, this queue is full of tree. So it's not yet empty. Then it will come back inside it until unless it reaches to the leaf of your binary tree. So in this particular case, you can see that every while loop, you just imagine this particular while loop is nothing but at every level, this level, this level, this level, this level, it is containing the information or keep looping through in that particular level and get the number of nodes, take all the values and sum it up and divide with the number of nodes, and that's the average of at that level. And that's where we are putting it into the this is again just for a debugging purpose to show you guys. You don't need it basically. So once I am out of this loop, what I'm saying, okay, my level is changed, level plus plus, it's again debugging purpose. That's why I have put the comment here, miscellaneous code just for understanding or debugging. And but what my average is, sum in this for loop, whatsoever be the sum was calculated, node count which was keep increasing within this while loop, so it may be 2 or 3 or 5 or whatever it is. So once you have calculated it, I'm just putting it to the list, which is a double, if you can see right here, and this is nothing but the output, which is what we are displaying over here. So let's run a program, and once this is, so once you are coming out of that particular level, you counted the average, then you say, hey, my inner level node queue is now this queue, meaning that I'm done with this, now traverse further. And that's how it's keep looping over and over. Let's run this program and see what's gonna happen. Alrighty, for your debugging purpose, I just put it in a, so sum of all the nodes at level 1, what is going to be? Level 1 is 1 and count is 1 because there is no other node at that level. That's good. Sum of all the nodes value at level 2, this is my level 2, okay, is 5. Yes, 3 plus 2, 5. And node count is 2. Okay. What is happening at this point? I'm just I mean, I have not printed that thing, but this is at this point of time, it is summing up and dividing the number of counts by 5 or by like 11 and so on and so forth. So number of nodes at level 3 is the sum is 6 plus 5, 11. Yes. Count is 2, 1 and 2 at the level. 8 plus 7, 15. Yes. Level 4 is 15, node count is 2. Let's see the outcome of it. So my first average will be 1.0. Yes, there is no other node. 2 plus 3, 5 divided by 2 because number of nodes were 2, 2.5. Good. 6 plus 11 is divided by 2, which is 11.5, which is 11, and divided by 2 is 5.5. Then 8 plus 7 is 15 and divided by 2 is 7.5. So you are kind of calculating the average at each level, and the way you are calculating is that number of nodes in that level and the value of each node at that level. So let's tweak it a little bit, and I am gonna add another so this is my output basically. So I'm just adding another node, assuming that this is not in this picture, but let's assume that I'm adding right to left to 10. So root right to left, let's say assume that I am adding another node here which has a value 10. So let's assume that that has been added. So how many nodes at that level? 6 plus 5 plus 10, which is your 21, and number of nodes will be 3. So what could be the outcome? Let's see. So I have uncommented that piece, and let's see what is going to happen. So we saw 1 is 1, 2 plus 3, 5.5 is fine, 2.5 is fine. Now third level, when we reach to the third level, now 21, because we just added node number 10. So 6 plus 5, 11 plus 10, 21, divided by number of nodes, 1, 2, and the 10 is 3. So 3 nodes basically. So 21 is divided by 3, and that's a 7.0, and 8 7 plus 15, and that's the average of it. 8 plus 7 is divided by 2 is 7.5. So this is how you can calculate the average of a binary tree at each level. And look at these two while loops. Why we have two while loops? In previous problem also we have two while loops. So why we have two while loops? One is traversing to make sure that it is reiterate once you are done with the level. Second while loop is only traversing through the level. So let's say you have 100 nodes over here. So it is this while loop is executing for that level, and when that level calculation is done, this while loop is done and it will be out, and it will go to this particular node. So that's how we are calculating this particular problem. Let's talk about the complexity quickly. Number of nodes, because you know that you are gonna traverse all the nodes which are gonna calculate your average. So definitely order of n, and space complexity is as well, because you are gonna traverse all the nodes, and it is, so that's what I have mentioned here, the maximum number of nodes, and for the time complexity we have to traverse all the nodes where n is number of nodes. So this is pretty much is the problem solution of this particular thing. I'm gonna solve another problem of the binary tree range sum, and I will be covering 3 or 4 more problems of binary tree, and then I will consolidate another video how you can figure it out that all 3 to 4 or 5 problems of binary tree can be solved using the same mechanism, but little bit tweak in the algorithm.